All right, we want factors of 5 that add to 6. So that's got to be 1 and 5. This factors as x plus 1 times x plus 5. So where each factor is equal to 0 is going to be a solution. I can see simply that that is x is equal to -1 as well as x is equal to -5. Okay, looking at factors of 14 that add to -9 would have to be a -2 and a -7. So this thing factors as x minus 2 times x minus 7. And the places where those two factors are 0 are x is equal to 2 and x is equal to 7. Every equation that we're factoring has to be set equal to 0. And so this is one of the few that appear within the homework. I'm going to subtract 2x and 24 from both sides. This equation is x squared minus 2x minus 24 is equal to 0. So I want factors of -24 that add to a -2. That has to be -6 and +4. Therefore, this thing factors as x minus 6 times x plus 4. These factors are equal to 0 at 6 and -4. All right, here we can move a greatest common factor, which is simply going to be just a number, which is 8. Changing the equation to x squared minus 81. And I'm done with the 8. I just have to factor the x squared minus 81. Now this is a difference of two squares, which means it's going to be x minus 9 times x plus 9. We can use the same logic as before though, where, okay, I'm looking to -81, and technically there's a 0x over here. I need factors of 81 that add to 0, which would have to be -9 and 9. So you can still use this idea. And now that it is factored, I can ignore the 8 and note that x equals 9 is the solution, as well as x is equal to -9. Again, I think we can remove a factor of 8 from every single term. Looks like the greatest common factor is 8. We're left with x squared plus 18x plus 81. So somewhat similar to question 4, except now there's a middle term of 18. So I'm noticing that had this been a +9 and a +9, well, that would go to 18. I'm guessing that for this problem, for a +81, I'm going to use 9 for both factors. This equation factors as x plus 9 times x plus 9, which you could simply write as 8 times x plus 9 squared. And really this means there's only one number that makes the equation 0. It would have to be x is equal to -9. So between questions 4 and 5, question 4 was a difference of two squares, which has a special factorization, a plus and a negative with the same number. And this one, it's actually a sum being squared. So everything is going to be positive. You still get an 81, but then you're going to double this number to get 18. And -9 is the answer, and that's it. Again, I'd like to set this equation equal to 0 simply by adding 45 to both sides. And there's definitely a greatest common factor of just 5 that can be factored out. I'm left with x squared plus 6x plus 9. And I want factors of 9 that add to 6, which would have to be 3 and 3. So this is a lot like question 5, where this factors as 5 times x plus 3 times x plus 3, or simply 5 times x plus 3 squared. And again, we have just one number that makes this equation 0, and that is -3. For question 7, the greatest common factor is not just a number anymore. We actually can remove both a 2 and an x. which gives us 2x times x squared plus x minus 20. So we are completely done with this 2x part, and now we're just dealing with this quadratic. And I think we can again find factors that work. Things that multiply to negative 20 yet add to a 1 would have to be a positive 5 and a negative 4. This factors as 2x times x plus 5 times x minus 4. There are three numbers that make this equation 0. X equals 0, x is equal to negative 5, and x is equal to positive 4. I'll start by subtracting 42x to the fourth from both sides, changing the equation to x squared minus x to the fifth minus 42x to the fourth is equal to 0. And my greatest common factor is actually just going to contain x's, but you can remove an x to the fourth from every single term. I'm noticing that that should have been a 6. All right, when I take out x to the fourth, I'm left with x squared minus x minus 42 is equal to 0. All right, a negative 42 adding to a negative 1 would have to be negative 7 and positive 6. That's x to the fourth times x minus 7, x plus 6. Here we have a situation where even though that's an x to the fourth, it still is only x is equal to 0, which makes that 0. Here this is going to be x is equal to 7, and this is going to be x is equal to negative 6. All right, now we come to a situation where it might not be as easy to guess the factors because I can't remove a greatest common factor, and I'm beginning this equation with a 4. So let's use this idea of we'll take the 4 and the 1, which multiplies to simply 4, and we'll find factors of 4 that add to this 4x in the middle, which only one option. It would have to be not 1 and 4, but 2 and 2. What we're going to do is take the original equation and split up the 4x into a 2x plus 2x. We can then remove the greatest common factor from the first two and last two terms separately. We can remove a 2x from the first two terms, leaving us with 2x plus 1. The last two terms only have 2x plus 1. Only have 1 as a greatest common factor, leaving us with 2x plus 1. But this trick gives us the same factor which can be removed another time. 2x plus 1 times 2x plus 1, which, as we've seen before, is really 2x plus 1 squared. You could have noticed at the beginning that, oh, well, maybe we have to have a 2x and a 2x. This is going to work out nice. It would only be a 1 and a 1. You probably could have guessed this as your answer as opposed to taking this longer approach. But either way, we do arrive at the same factorization. What I'm going to do this time, instead of guessing the answer, I'm going to take 2x plus 1 and set it equal to 0. I would subtract 1 and divide both sides by 2, and this is my answer of negative 1/2. Let's see if we could use a guess and check approach instead of this multiplying the first and last two terms to factor our equation. Like, here we had a 4x squared, so I could have guessed a 2x and a 2x. Here there's a 25x squared. Seems like there's more possibilities, but maybe this thing factors as 5x and 5x. Likewise, I want a positive 9 at the end, so a 3 and a 3 could be a good choice, provided that you make both of them negative. Does this work? I know the 5x and the 5x gives me the 25x squared, and the negative 3 and the negative 3 gives me the positive 9. The only thing that you'd want to make sure is that this negative 30x comes out of our equation. So I can check the first and the last terms just like really quickly here. So again, this is just for checking, but 5x times negative 3 is negative 15x, and the negative 3 times 5x is also negative 15. When you add those two together, it does give you a negative 30x. Okay, this is really good. I know the whole thing factors as 5x minus 3 times 5x minus 3, or just 5x minus 3 squared. I therefore can take 5x minus 3, check to see where it's equal to 0, but by adding 3 to both sides and dividing both sides by 5 gives us our final answer. All right, so 3x squared minus 11x is equal to 4. I will subtract 4 from both sides. And I'm going to forego trying to guess. The last two are easy just because the numbers worked out really nice. Here, there's just too many cases to consider. So I'm going to jump right to this idea of multiply the 3 and the negative 4, which gives us negative 12. And think of a way to split up negative 12 so we get a negative 11 from the sum of the factors, which would have to be negative 12 and a positive 1. I'm going to rewrite the equation as 3x squared. It doesn't matter which factor I put first, so I'll just go with the negative 12x, then the plus 1x minus 4. Removing the greatest common factor from your first and last two terms gives us, okay, we can take out a 3x and we're left with x minus 4. That's looking good, because if I remove 1 from the last two terms, I also get x minus 4. This and this are the same, which can be factored out once more. We're left with 3x plus 1, and that's equal to 0. The places where this is equal to 0 are x is equal to 4. And again, you can take 3x plus 1 and set that equal to 0 itself and solve for x. I would subtract 1 from both sides, divide both sides by 3, and that is our final answer, 4 and negative 1/3. All right, so maybe, let's see, instead of guessing, I think this one will be somewhat similar to the previous question, where if you look at the product of 2 and 7, you get 14. It's positive 14. But here, if it was negative 14 and negative 1, those sum to negative 15. I'm going to split up 2x squared minus 15x plus 7 into 2x squared minus 14x minus x plus 7. Removing the greatest common factor from the first two and last two terms, we get 2x times x minus 7. And here, all right, really, I'm going to factor out a negative number, negative 1. That way we get another x minus 7. If you just factored out 1, the two factors would not match up perfectly. Here they do. I can now remove x minus 7, and I'm left with 2x minus 1. The places where this is equal to 0 would have to be just by looking at this one, x is equal to 7. And my other factor is equal to 0 if I add 1 to both sides and divide by 2, 1/2. Okay, here I'm removing a greatest common factor of, well, at least x and a 2. Taking out 2x, we're left with 3x squared plus 16x plus 5. Okay, I think I'm going to factor 3x squared plus 16x plus 5 by using our trick of multiplying the 3 and the 5, which gives us 15, and I see the factors are clearly going to be 15 and 1. So copying this whole equation down, actually I think I'm going to work this out separately, where I want to factor 3x squared plus 16x plus 5. I'll factor it and put it back into the equation. So that is, let's see, if we just look at 3x squared plus 16x plus 5, I can replace 16x with 15x plus x. Removing the greatest common factor from my first and last two terms gives me 3x times x plus 5 plus 1 times x plus 5. Now removing the x plus 5 gives me x plus 5 times 3x plus 1. This is equivalent to this, so I'm just going to place this here. My equation is really 2x times x plus 5 times 3x plus 1. Where is that equal to 0? So I just took this, put it right there. The place where my equation is equal to 0, clearly from this factor has to be x is equal to 0, as well as x is equal to negative 5, but also wherever 3x plus 1 is equal to 0, which is going to be equal to 0 after subtracting 1 and dividing both sides by 3, negative 1/3. Okay, there's a greatest common factor that can be removed here of definitely an x cubed, but also I'm guessing 4. I think that divides into every single number. we're left with 4x cubed times, would have to be x squared plus 13x plus 42. Okay, I think we probably could just guess the factors of this one. Things that multiply to 42 yet add to 13 would be 6 and 7. So I can immediately just say the factors of this are x plus 6 and x plus 7. And the numbers that make this 0 are x is equal to 0, x is equal to negative 6, and x is equal to negative 7. And those are my three solutions. I'm going to remove a greatest common factor of 5 and x. I'm left with 6x squared plus 7x plus 2 is equal to 0. Okay. Now the factors here, all right, I'm going to go through our process of multiplying the 6 and the 2, which gives me 12, and factors of 12 that add to 7, or okay, it's just 3 and 4. So I'm going to break this apart separately and say, let's look at just factoring the 6x squared plus 7x plus 2. I'll write the 7x squared as, I'll go 3x and 4x. I'll remove the greatest common factor from my first and last two terms. So that would be 3x times 2x plus 1 plus 2 times 2x plus 1. Now removing the 2x plus 1 gives me a 3x plus 2 left over. I'm now going to take this and substitute it back into the original equation. So I had 5x, and I'm going to replace the 6x squared portion with 2x plus 1 and 3x plus 2. And the place where this is equal to 0 must be x is equal to 0. If I set 2x plus 1 equal to 0, that's equal to 0 at negative 1/2. And if I set 3x plus 2 equal to 0, that's equal to 0, x is equal to negative 2/3. And those are my three solutions. All right, and for this last one, my greatest common factor is an x to the 4th, but also I'm thinking it's just 10. 10x to the 4th. If I missed a number, I can always try to factor out more in the next step. There's nothing wrong with that. It would only mean that this wouldn't be the greatest common factor, but it would still take us in the direction we want to go. All right, so removing 10x to the 4th, we're left with 15x squared plus 29x minus 14, and that's it. Yeah, 29 is prime, 15 is a 3 and a 5, 14 is a 2 and a 7. There are no common factors that can be removed. So I think this one's just going to be a little bit more challenging than the previous, where you could try to guess the factors. Maybe you could get it. Nothing wrong with that. But, I mean, this process is difficult if the values you're multiplying are large numbers. This is negative 210. All right, I'm going to just do a little bit of guesswork. I need two factors of negative 210, which add to a positive 29. I'm just going to go through dividing some numbers into 210 and see what comes out. Okay, after trying a few options here, I got 35 and 6, and I put the negative on the smaller number because the sum in the middle is a positive value. So 35 and negative 6 are going to factor this expression. Well, let's see why. We get, if I just focus on the 15x squared plus 29x minus 14 part, I'm going to write 29 as, I'll go plus 35x minus 6x minus 14. Okay, my greatest common factor is going to be a 5x from the first two terms, which gives me 3x plus 7. And if I take out negative 2, I also get 3x plus 7. This is great because 3x plus 7 is the same in both parts. If I remove it, I'm left with 5x minus 2. I'm now going to plug that into the original equation where we had 10x to the fourth, 3x plus 7, 5x minus 2. These factors are equal to 0. This entire thing has just one 0. X is equal to 0. 3x plus 7 is equal to 0 at negative 7/3. And 5x minus 2 is equal to 0 at x is equal to 2/5. Those are the three solutions, and that is it for this homework.